a single vertical well, some of them have a single vertical well and a single horizontal well, some of them have a vertical well and a couple of horizontal wells. Very few of them so far have 4, 5, 6, 8, 10, 12, 14, 16 wells. But eventually most of them will have a large number of wells, 6, 8, 10, 12. Why? Because the industry is finding out by doing experiments elsewhere that that is the most economical way of doing things. If you have to bring the big rig to one place once to drill multiple wells, that's a lot better than having that big rig here today, 5 miles away tomorrow, another 5 miles away the next month, and then it has to come back sometime in the future to drill the second well. That's moving all your equipment around. That costs money. Same thing with the fracking equipment. Okay, so to optimize things, it's better to do everything at one time in one place, except that one time now becomes elongated. So this is what was, about a year ago, the largest frac job ever done by anybody. It was done by Apache in northeastern British Columbia. As you can see, it looks a little bit bigger than the pads you've seen in Pennsylvania so far, because there's 16 wells on this pad. They're actually being fracked at this point in time. So the surface impact here is negligible. Would you call this heavy industrialization? I would. How long does it take to drill 16 wells and frack 16 wells? Here today, gone tomorrow?
No.
No, a month?
No. 2 years.
A year?
2.
Couple of years? And when that's all done, what's left? One little wellhead and one little 500-gallon plastic tank? No, you got 16 wellheads and you got a series of very large tanks collecting brine for a long period of time. So the surface impact is larger, the remnant surface impact is larger, the industrial impact is larger, the equipment is larger, the period of time that this is under active development is larger. You be the judge of whether the impact is less. This is another image similar to the one I showed you in cartoon style of the Dallas-Fort Worth Airport. Again, this is northeastern British Columbia. You'll notice that each one of these convergence points is a pad. And from each pad there is a number of wells, and we're going to focus on this one. There's 16 wells that come out of this pad. Notice that all the wells are either going in one direction or in the opposite direction. Why? There's another mini-myth here. I'm injecting, many seem to eject a bunch more mini-myths. One of the mini-myths is, well, because of directional drilling, we can put down a pad here and we can drill wells in all directions. 360 degrees like spokes of a wheel. How many times have you heard that from a landsman? Wrong. Geologically stupid. The fracture patterns that I showed you, these are fracture patterns we're trying to reopen so that they're superhighways for the gas. Those fracture patterns are given to us by geology. 350 million years of fracture formation, they are what they are, and you want your well to be oriented perpendicular to one of those joint sets, and that means your wells are all going to go more or less in one direction or in the opposite direction, which is the same direction geologically speaking.